Okay, guys, so we need to practice equations to tables. So the first thing that we're going to look at is just remember our equation. So we've been learning about y equals mx plus b, where b is my y-intercept, and that is the value of y when x is 0. So I can find it in a table at 0, and then your b, your y-intercept. And then m is your rate of change. That's your change in y over change in x. When you're looking at it in a graph, it tells you if Louis is going uphill or downhill, okay? So in this equation here, let's see. Okay, it has the equation y equals 1/2 x minus 7. So I'm going to look here, and this minus 7 is my y-intercept. So that means that the table should be going through 0, -7, okay? So here, 0, 7, well, that is not true. It needs to be -7. 0, -7, that looks good. 0, 7 does not. 0, -7 looks good. All right, so we are already down to either C or D, okay? So the second piece is my rate of change, and sometimes that's kind of difficult in tables. So what I want you to do is go ahead and look at the substitution piece. So what we're going to do with substitution is we're going to take the x, and we're going to choose an x value from the table and plug it in, okay? So each time I have this equation, y equals 1/2 x minus 7. So 1/2 whatever it is minus 7. 1/2 something minus 7, okay? So I'm going to plug in an x value. So let's say I'm going to do, I don't know, -4. Well, let's see. This one has -4. This one has 2. Okay, let's just do positives. Let's start with positives because I know you guys don't really love negatives and I don't want to be confused. So let's do the 2 and let's try the 8 and see which one matches. And then we can go from there. So 1/2 of 2 is 1. 1 minus 7 equals, well, you can't subtract a bigger number, so add the opposite. So 7, different sign subtract, 7 minus 1 is 6, so I have -6, okay? So that's matching here. 1/2 of 8 is 4. 4 minus 7, again, you can't subtract a bigger number, so add the opposite. Different sign subtract, 7 minus 4 is 3, and I keep the sign of the bigger number, so -3. So those two both match, okay? So that means we're going to have to try again, okay? Let's see. Let's try 6. So 1/2 and something minus 7. 1/2 and something minus 7. Okay, so let's do 6 and -6, I guess. 6 and -6. Okay, 1/2 of 6 is 3. 3 minus 7, add the opposite, different sign subtract, so -4. That looks good. 1/2 of -6 is -3. So we're going to do -7, add the opposite is -10. Well, that matches too. Okay, so we're going to keep going. Now, one thing, maybe somebody has noticed, maybe you haven't. But look here. We have -6 as a value for 2 and -2. Okay, in a straight line, you will not be able to have two different y values, or one y value for two different x values. So we're going to go ahead and just finish these last two pieces of substitution. So yes, this problem has been a little bit lengthier than it needed to be, but I want to make sure you guys are truly understanding the substitution piece. So I'm going to plug in the -2 and the -4 and see which one works. Okay, so half of -2 is -1 minus 8. Add the opposite, same sign, add and keep, -9. Well, that does not match. Okay, so let's look here. We have -4. Half of -4 is -2 minus 7. Boom, boom. Add the opposite is -9. Well, that one matches. So my answer is D. Okay, so guys, really with tables and equations, it's going to come down to substitution. All right, let's try this next one. This next one's a little different. It gives us a scenario. It says, Pierre's selling homecoming mums for $10 plus an additional 75% per decoration added. Which table shows the relationship between the cost of the mum, C, and the number of decorations, D? Okay, so what we are used to is X and Y. So X is my decorations and Y is my cost. Okay, and then I see this word per. So it says 75 cents per decoration. So 75 cents for each decoration. And then I have this $10. Well, that's just a one-time price. That's an initial fee essentially, right? So we're adding $10 no matter what. So that means that my 10 is my y-intercept. So I'm looking for one with a value of 0, 10. This has 0, 0. Nope. This has 1, 10, 75. Okay. 0, 10, that looks good. 2, 11, 50. Well, just because these don't have a 0 doesn't mean I can eliminate it. Okay. So, plus an additional 75 cents per decoration added. Okay, so let's see. If I add one decoration, so there's 0 decorations, it's $10. If I add one, it's an additional 75 cents, so $10.75. If I add 2, it's 75 more cents, so $11.50. If I add 3, let's see, 75 more cents, so that's $12.25. If I add 4, it's going to be $13. Okay, so I just went ahead and made my own table. It was easier for me. Okay, so I'm down to either B or C. And if I look at B, 1 and $10.75, well, that looks fantastic. 2 and $20, well, I'm not adding $10 each time. I'm not multiplying the 10. So no, that one's not wrong, or not right. But these look good so far. So it looks like our answer is C. Okay. And let's give this one a shot. The table below represents which of the following equations? Okay, so this one's a little more difficult because we do not have a y-intercept in the table. So all we're going to do on this one is we are going to go ahead and substitute, okay? So I am going to choose an x value. Let's say I want to choose 3, okay? And I'm going to just plug 3 in for each x, okay? So like if I started with D, D says 3 plus 5 equals 8. Well, I'm looking for 10, right? So no, it's not D. 2 times 3 plus 4. So 2 times 3 is 6. 6 plus 4 is 10. That looks good so far. Let's try this one. So this is 3 plus 2 is 5. Well, no. B's gone. 6 times 3 is 18. I need 10. Wow. I found it pretty quickly. All right, so that's just using substitution. So guys, most of the time substitution will just work for you when you are looking between an equation and a table, okay? So now let's go ahead and do this last one together. So it says we have, I'm showing you the last one you're learning, okay? So again, we know with our equation of y equals mx plus b, right? That the b is my y-intercept, okay? So the 14 is my y-intercept. That means that is the value of y if x is 0. So I'm looking for 0, 14. This has 0, 0, no. 0, 14 looks good. 0, 14, 0, 14. Amazing. Okay, so now what I'm going to do is look at that. They all have such different values. I like the number 10. So I'm going to try to plug in the number 10 in for x, and we're going to see what happens. So my equation is 0.5 times x plus 14, okay? So 0.5 is 1/2, right? 1/2 of 10 is 5. 5 plus 14 is 19. So let's see, this has 10, 15, so no, because I'm looking for 10 is my x and 19 is my y, right? 10, 64, no. 10, 70, no, I already eliminated that. 10, 19, that looks good. All right, so guys, this is just substitution. You select an x value from the table, plug it in, and see which one gets you the proper y value. So that, my friends, is equations and tables. I hope this helps.